In section 9.2, we discuss quadratic functions. This video will work your homework problem number 30, found on page 556. The learning target for this section is I can graph quadratic functions of the form y equals ax squared plus bx plus c. In the quadratic function y equals ax squared plus bx plus c, the value of b translates to the position of the axis of symmetry. So remember that when you're looking at this form, whatever number is here, that is in the place where the b is in the standard form, then that number is going to control the position of the axis of symmetry. And since the axis of symmetry is very important to the graph of the function, knowing that that b is going to control where that axis of symmetry lies can help us to solve problems that involve either the axis of symmetry of the quadratic or the vertex of the quadratic. Now, the axis of symmetry for the graph of a quadratic function can be found by using this formula, x equals negative b over 2a. We can also use the same formula to find the x-coordinate of the vertex of the graph. And the reason for this is because the vertex always lies along the axis of symmetry. So let's think about problem number 30. The Riverside Geyser in Yellowstone National Park erupts about every 6.25 hours. When the geyser erupts, the water has an initial upward velocity of 69 feet per second. What is the maximum height of the geyser? You are told to round your answer to the nearest foot. Now, the two questions that follow are designed to help you to solve the problem. First, they're going to ask you what is the initial height of the geyser. Then they're going to ask you what function gives the geyser's height t seconds after it starts erupting. But again, these questions are merely designed to help us to find out the answer to our main question, which is what is the maximum height of the geyser? Now, for this problem, we do not have to actually graph the function in order to find our answer. What we really need to find out is the vertex. Because when we find the vertex, we will be finding the maximum value of the function. Keep that in mind as we work this problem. Okay, so the initial height of the geyser. Well, if you think about it and you think about what a geyser is doing, the water is coming up out of the ground. So the initial height of the geyser would be 0 feet because it would be ground level. The second question that they ask us to help us get us started is what function gives the geyser's height, h in feet, t seconds after it starts? Well, if you'll remember from our discussion of this, we can write the function as h equals, then we use negative 16t squared. That is the impact of gravity. Then we're going to write plus, and we're going to put in the initial velocity of the geyser, of the water actually, which is 69, and multiply that by t. That will be our linear term for our function. And then lastly, we will put the initial height of the geyser, which is 0. So our function written in standard form would be h of t, or just h, is equal to negative 16t squared plus 69t. Now, if we use this function correctly, we should be able to find out the maximum height of the geyser. Well, remember that when you're dealing with quadratic functions, then the quadratic function will either open upward or it will open downward. In the case of our function, since the quadratic term, that is the first term, has a negative sign, that tells us that this particular function opens downward, and its basic shape would look like this, which means that the function has a maximum value at the vertex. So if we find the vertex, we will be able to determine the maximum value of this function. And once we determine the maximum value, we can answer this question. So now you have to remember, well, how do we find a vertex? Well, if we're given a function, we start by finding the equation of the axis of symmetry. To find the equation of the axis of symmetry, we use x is equal to negative b over 2a. In this case, a is going to be equal to negative 16, b is equal to positive 69, and c is equal to 0. So for x equals negative b over 2a, I'm going to plug in my b value and my a value, and I'm going to simplify this. Now, that's an approximation sign because I'm going to approximate it. So if I divide through and take negative 69 divided by the quantity 2 times negative 16, this gives me a value of 2.15. And 2.15 then is the equation of the axis of symmetry. So the axis of symmetry actually has the equation x equals 2.15, which means that the vertex has an x value, or an x coordinate rather, of 2.15. If I find the y coordinate of the vertex, I will be finding the maximum value of the function. So I'm going to take the 2.15 and I'm going to plug it in to my function and use that to determine the maximum value. So I would do negative 16 times 2.15 squared plus 69 times 2.15. And if you were to use a calculator to compute that, then the value that would come back would be 74.39 feet. Now, when you go back to your original problem, it gave you specifications about how to write your answer. It said, round your answer to the nearest foot. Well, the nearest foot would be the nearest whole number. So rather than writing 74.39, I'm just going to say that that is 74 feet. Again, I'm rounding that to the nearest foot. And my vertex has coordinates of 2.15, 74, which means that the maximum value of the function is 74. And in this case, that would be 74 feet. So let's write our answer in a complete statement. The question asks us, what is the maximum height of the geyser? So our answer would be, the maximum height of the geyser is approximately 74 feet.